Thank you very much for the invitation to speak to you today. I do count it a privilege. Primarily, the presentation is about structural safety, and I'm coming at it from the perspective of failures and their investigation. So you can log it, as Mariette has told you, in the appropriate category for your CPD points. It tends to be a longer than normal presentation, probably around 1 hour, depending on how much I ad-lib. So if you need to, if you have something else to do or need to leave or you get bored, do please feel free to drop out. I also apologize if you hear any background noise. We have literally just moved house and there's still a few suppliers doing their things in the house. So practicing the art of structural engineering, that is designing elegantly and efficiently and economically, is one thing, but doing it competently and safely and avoiding the pitfalls and bear traps and staying in business is quite another matter, because things do go wrong. I'm going to start by showing you a few hard-hitting video clips which might shock some. So by the very look of it, this is an old bridge which has been rather badly maintained. Watch the white truck going from right to left across the screen. And that poor little white car gets sandwiched underneath the falling debris. And I always think the little white car perched on the left-hand edge had a very lucky escape. That was a half-joint failure of a road bridge over a dual carriageway with one fatality. This is an architect's impression of the Florida International Bridge. It was a two-span precast concrete cable-stayed footbridge with the longer span over a motorway and the shorter span over a river. That's a picture of the longer span being bogeyed into position and about to be lowered onto its abutments. Significant cracking had been reported, but the engineer dismissed it as being non-critical. And you can see that work is ongoing, even though the road is open to traffic. So watch what happens. So the mobile crane denotes the point where some post-tensioning takes place. So that's a picture of the aftermath. In this case, there were 6 deaths, incredibly not more. And the report on the collapse determined it as essentially a punching shear failure in that area there. This is another one, the Ponte Morandi in Genoa. You'll immediately notice that in the middle of the picture, one of the 3 main A-shaped pylons is missing. And this diagram says it all. And they've also, of course, had some collapses in other parts of the world. This one is in India, at Kolkata, with 1 death. And one that's fresh in everybody's memory is Surfside, Miami. One of 3 12-story beachfront condo towers built in the early 1980s. There was a north and east tower also. This is what happened as captured by surveillance CCTV at 01:25 hours. And the video clip takes place over a 12-second period of time. I'll apologize in advance for the lead-in, but I'm not competent enough to delete the first part of this. Oh, here we go. It's working. Rather dramatic photograph or video. So it's rated as the 3rd deadliest building collapse in US history. the Hyatt Regency walkway being the worst. And then, of course, the other two towers in this complex were subsequently demolished. An investigation is still underway, I believe, led, interestingly enough, or co-led by Glenn Bell. Some of you know him. He is a fellow of IStructE, and he's an ex-board trustee member. And Glenn currently heads up CROSS US. The focus is very much on known reinforced concrete degradation at the main transfer structure level above the ground floor car park. Water ingress and rebar corrosion were well documented, but nothing had been done by way of remediation. But as with all these, other causation factors may come to light in due course. Now, for one, I'm currently involved with as expert witness. I think it's coming to a conclusion, but because it's sub judice, in fact, it's a criminal prosecution, I can't give any real detail. It's a typical dockside scenario. It could be anywhere in the world, could be Cape Town. The crude-looking piece of equipment used during the unloading of a ship's hold is called a hopper, H-O-P-P-E-R. And inside it is an inverted chute or funnel. The large dockside crane to the right has a grab, which you can see on the ground, which holds in excess of 30 tons of coal. It's too big to directly fill a lorry, so it fills the hopper. And I want you to imagine a lorry reversing into that opening there. An operator sitting here controls a hydraulic clam valve at the bottom of the chute to fill the lorry as it slowly drives out. So watch what happens. Those two photographs are not part of the same sequence, but if you can visualize that lorry sitting there, the hopper has moved over to here. So just to restate that, the hopper was originally straddling the lorry. It's now only half the height it was. Its legs are folded underneath it, and instead of crushing the lorry, it has fallen to the one side. The poor operator never stood a chance. He was instantly crushed to death as the legs and his cabin folded beneath the collapsing hopper. The cladding in that photograph has been removed to allow the rescue services to cut away the structure to recover his body. So this is what happened in essence. Thompson Dock in Belfast is where the famous ship Titanic was built, and also its sister vessel Olympic. The dock, which was nearing completion when the new ships were signed for, ended there, with the steel dock, or the caisson as it's called, in the position shown in the photograph. But that was too short for the new generation of vessels, so Thompson Dock was extended out to there, and the caisson was placed in the outer position when they were building it. The gate, the steel gate, was in dangerous condition. It was a floating gate, obviously, and was temporarily buttressed to prevent collapse. So the client instigated a design and build contract to provide a new reinforced concrete sea defence wall as shown on plan. Because Thompson Dock is a listed monument, the new permanent wall, in inverted commas, had to be capable at some stage of being deconstructed to revert the dock to its original state without damaging it. So the temporary work solution was to construct a cofferdam, like that. The outer sheet piles, you can see them, were supported by 6 horizontal steel girders, pre-assembled in 3 pairs to form 3-dimensional girders, stacked one on top of the other. The girder spanned some 35 meters across the mouth of the dock. That's what the new permanent reinforced concrete wall looked like in completion, but I'm showing you the picture at this stage because you can see one of the 3-dimensional steel girders ready to be taken away for recycling at the end. That's a construction photo as dewatering was nearing completion and all was going well. They reached the bottom and they started to remove decades of accumulated mud and silt. And then suddenly during lunchtime break, the lads in the site canteen heard a very loud bang, almost immediately followed by a lesser one. And it was eventually traced to the location shown by the star. And of course, it occurred in the most heavily loaded bottom girder at one side. The inner main diagonal tension member had parted company with the outer top cord. I do apologize, but the quality of that picture isn't great, and you'll see it much more clearly in this photograph. A full penetration butt weld had been specified, but what you see is a small area of weld which held, causing a small part of the flange and web to rip away, whereas most of the weld has parted company very easily, more what would be expected from a fillet weld or a full pen butt weld which hadn't been properly preheated or formed. The consultant commissioned a very expensive and sophisticated 3D Plaxis soil structure interaction retroanalysis, and it showed that the girder was not at critical utilization levels, and the welding expert concluded that the welding was indeed deficient. It seemed a fairly watertight case, if you pardon the pun, but it dragged its way towards court with the costs ever mounting. So the two parties went to mediation and the horse deal was done, the details of which I am not party to, except to know that a very significant sum of money was involved, and I'll probably come back to that at the end of my presentation. So, as the title of this presentation suggests, I'm looking at what has happened over a period of quite a number of years. I first presented a version of this talk to my fellow RPS directors in 2017. They wanted to know more about the new line of forensic engineering, which I had diversified into. I was tired of working at the coalface and having clients kick me and look for every excuse not to pay us. So I diversified into forensic stuff. I'd always done a little bit of it. And the directors also wanted to know why it was generating such exceptional profit margins. So when they saw the presentation, they decided it should be rolled out to all the 200 plus staff in the Belfast office. And we did that over 4 lunchtime sessions to generate an awareness of some of the issues. And everyone attended, right from the senior management down to the most junior level in their peer groups. Even the admin and IT people sat in, but maybe for them it was the free lunch that enticed them. The analysis, the presentation was based on an analysis of several hundred expert witness reports I'd done in the previous 20 years, and it highlights themes and trends and recurring issues, and the emphasis, of course, being on the lessons learned from those and the mistakes to avoid in future. In all these cases, there are common and recurring themes, and the cases generally tend to be cross-discipline and there's seldom one standalone issue. It's always a combination of factors. Time wouldn't permit me to go into this in depth, and I will be leaving out a lot of detail and case histories that I could give and normally give. I'd also say that some of the terminology might be UK based, but hopefully the same principles apply to you. So it tends to be smaller companies and practices who get into trouble. It's very easy to be critical in hindsight because it all seems so common sense when you find out what the causation was. And always remember, it's there, but for the grace of God, go I. It could be you or me next time around. So we're starting off with contractual issues. Always avoid ill-defined general scope type appointments. Be specific as you can, even to the point of where you might only, in an interface or gray area between you and the architect, state that you're only giving advice on a particular issue. Have a schedule which shows the the scope of what you do, what you're going to provide, what you're not going to provide, and any explanations. And be very, very careful to understand any specific employer requirements. That seems like a no-brainer, but you'd be amazed at people who haven't read the client's specific details. Larger companies will have the necessary skills in-house. Smaller companies won't, and they're often tempted to stretch beyond their experience. And this particular consultant had done a lot of public realm schemes in urban environments, but took on a scheme in a semi-marine environment, a new seafront promenade away up in the north west coast of Ireland. And the first big storm which rolled in from the Atlantic found the structures wanting. Scour and erosion meant that these had to be deconstructed and rebuilt in a much more robust fashion. I've included this little case history because every lecture should have a little bit of humor. I'm not a golfer. Those of you who are will chuckle, but this is a typical driving range canopy, and the ball trajectory is shown in the dashed green line. This particular engineer, obviously not a golfer, decided to ignore the old maxim, if it ain't broke, don't fix it, and changed what was a rather traditional design, and you can anticipate what happened next. Balls started to ricochet back, and people were getting injured and were suing the owner for personal injuries. Never be tempted to buy work and take shortcuts as many engineers do. It's very easy for the architect to change his scheme or her scheme on the CAD drawings, but it may cause you a complete redesign. So don't get sucked in. Ensure you're going to get paid for these changes and the sort of knock-on effects in the design. And a very important lesson, never do favors for a client in difficulty if something goes wrong without a proper agreement in place. I've seen that go horribly wrong because there's a tendency to try and impress your client, to rush into a solution, and invariably without thinking through the consequences sometimes. CDM, health and safety regulations. I don't know what the equivalent legislation governing construction design and management is called in Southern Africa, South Africa and the other countries, but this is what it is called in the UK. It's called the CDM Regulations 2015. So that innocent looking boundary retaining wall on a drawing of yours, for example, which you've designed and carefully detailed, make sure it's buildable. You need to have thought through the construction methodology. Make sure you put the key method statements in a box on your drawing so that the quantity surveyor sees it, and more importantly, the contractor sees it. It may not be the method the contractor eventually uses, but it must get incorporated into the contract documents for the contractor, first of all, to price it, and then secondly, risk assess it. And more importantly, if something ever does go wrong and you find yourself in front of a judge, you need to be able to demonstrate that you had carried out your own designer risk assessments and that you had conceived a way of building it safely. Contractors should, but don't always issue RFIs. They often think that they know better than the consultant, and they generally are clued on, but not always. A combination of these particular issues resulted in the collapse of 6 stories of precast concrete stair flights during erection of a stair core adjacent to a retail centre with one fatality. Windsor Park Stadium is where Northern Ireland play their home international football matches, and it's also home to a local club, Linfield. This was the COP, the West Stand at Windsor Park. Windsor Park was being demolished, and at the same time, Belfast City Council were redeveloping a leisure centre behind that West Stand. So this is a simplistic cross-section through the West Stand. The new leisure centre is to the left of the picture. The scheme involved a 2-story deep excavation for swimming pool and overhead changing facilities. It's alleged that the contractor had not included for temporary works because the designer hadn't highlighted the need for such. So there was nothing specific to price in the contract documents, and I'll come back to that point again. Many of you will instantly recognize that to avoid a slip circle type failure, a deep permanent contiguous secant piled wall is required. However, the contractor went to a two-man band consultant who designed what in essence was a mass concrete gravity retaining wall constructed using the trench fill technique. So approximate scale, just over 6 meters deep and slightly less than 3 meters wide. They excavated and they put in a bottom 100mm thick mud mat layer, concrete mud mat, also shown in grey. And just looking at that sketch, it just doesn't seem right to those of us who are engineers. Anyway, Northern Ireland played Finland on a Sunday evening in a European Cup qualifier with a capacity crowd in the stands, all doing their Mexican waves, and it was a very wet and stormy night. And this is what the main contractor found when he opened up the site the next morning. A view looking both ways. Overnight, the retaining wall had tilted inwards, as shown in both the photographs. And it was prevented, I think, from sliding as well by virtue of the mud mat. And the west stand foundations partially went, you can see them there, partially went with the temporary works. I think of significance in that left photograph is the tilt, the amount of tilt above the roller shutter door. And there in that photograph, you can see the main stanchions all starting to buckle. The movement continued, it was monitored, and within a few days, the stand had to be demolished as an emergency action. I've also been involved on behalf of the Health and Safety Executive Northern Ireland in criminal prosecutions where breaches of legislation has occurred, and sometimes I've acted against HSENI for parties being prosecuted. This was a building under construction. Ironically, it was the new headquarters for the Law Society in Northern Ireland in Belfast. And part of the first floor had been omitted to be retro-installed later as a steel and glass feature floor. So the support legs of the formwork system were in effect 2 stories high instead of the usual 1 story. The contractor, without seeking any professional advice, simply placed 1 layer of the formwork system on top of the other, a bit like stacking 1 table on top of another table. And the floor collapsed without warning during pouring of the concrete. You can see the wet concrete lying on the ground and the rebar in the foreground. The Polish squad, the 4 of them were seriously injured, but they were saved by the rebar wrapping around them as they fell with it. It's quite obvious what had happened. The bottom set of support legs were effectively twice the height they should have been, and some of them buckled, precipitating total failure. So let's move on to concept design stage issues. Outsourced surveys like topographical surveys and geotechnical investigations have been found to be erroneous. And when the witch hunt begins, the specialist company that did the work no longer exists. They've gone belly up, leaving huge liability issues. So always try to get your client to appoint and pay the specialist. If not, make sure you have a back-to-back appointment that mirrors your own agreement and conditions, and make sure the specialist has PI insurance, and always insist on a percentage markup on your fee for the privilege of organizing such a service. Ground conditions are always vitally important, even with houses, private residences. I don't know if you have peat in southern African countries. I certainly never heard of it when I was in Zambia. But with peat, it's not sufficient to pile the property because the land around it sinks relative to the hard spot you have just created, and sewers and drains and other services can sink. In that particular situation, I was able to put on overalls and knee pads and a safety helmet and crawl underneath this house. Do take a moment to read these points on the slide for yourself. As engineers, we need to be able to design efficiently for our client. It's very important, for example, to know the difference between foundation settlement and foundation subsidence, at least in the UK, because insurance claims will hinge on will hinge on that definition and hinge on what has been concluded in the report. I was involved in a major case which only settled recently, a 9-story apartment block. And in this case, the designer hadn't catered for the codified disproportionate collapse requirements, turning out to be a very, very costly mistake. Piling, and I'm speaking here from a UK perspective, I don't know what your conditions are in that part of the world, but piling is often a problematic area, particularly when CFA piling, that's continuous flight auger piling, is used because of the phenomenon of flighting, which I don't have time to explain just now. But if you're ever using CFA piles, make sure you specify the rotary cased version at the interface with adjacent buildings to avoid flighting and settlement. Then when specifying driven piles, many engineers do not know about negative skin friction. Negative skin friction is where driven piles which rely on skin friction in certain types of ground can be dragged down with time as the ground consolidates, causing differential settlement. And at least one major residential development had to be demolished in its entirety because NSF had not been taken into account. Load transfer platforms are another major area of concern if not constructed correctly. An LTP is an alternative to placing a reinforced concrete slab on top of piles. Instead, a thick layer of granular material is placed on top of the pile caps with embedded layers of geotextile reinforcement. It's a bit like a mattress, the devil, of course, being in the detail. I've seen quite a few failures of system retaining walls in my time. Reinforced earth is where the front retaining wall is built and the backfill is installed using layers of geogrid reinforcement inserted into the backfill so as to connect with the wall. And so the entire mass, that is the wall and the backfill, act as a composite entity. In this particular one, as soon as I saw it and was taking the photographs, I was able to instantly recognize the cause of the failure. It was because the geogrid reinforcement came in a 3.6 meter wide roll. It required to be cut into longer 6 meter lengths. Instead of that, the contractor simply rolled out the geogrid parallel with the wall in a weaker direction and thinking Christmas had come. Brickwork cladding on multi-story building facades is becoming an increasingly common problem. In that photograph on the right, note the bulging of the clay brick outer skin. It's an extreme compression and it's at the line of an intended horizontal soft movement joint. You'll see that some bricks have already spalled under the pressure. And as I say, it should have been a soft joint to allow room for vertical floor-to-floor expansion. Instead of that, it was mortared up, and the contractor knew what he was doing wrong because he applied a bead of mastic to make it appear that he had created the soft joint. And you can see a piece of that mastic hanging down. Not everyone knows that clay brickwork experiences irreversible expansion during the first 6 to 12 years of its life. Also, the responsibility for the design of joints tends to be split between architect and structural engineer, and that's when things get missed. And it's important that there is site supervision, otherwise shortcuts are taken, as happened in the Edinburgh School collapse. Adding water to concrete is a constant battle. People just don't seem to get it, that the strength and durability of the concrete is compromised as a result. I even, going down to the end of the slide, I've even had one case where deliberate sabotage was confirmed on the connection of a pumping main to a pumping station to try to shed blame on another contractor. I was appointed as expert engineering advisor and expert witness by a commission of inquiry in Hong Kong in the mid to late 2018. I was acting for the commission itself. The formal report was issued around mid-2020. The aim was to join up two railway lines as shown, the east-west line in the darker colour and the north-south line in the blue. And the linked up point, the linked location was Hung Hom Station in Kowloon. The sponsor was the government of Hong Kong, with 4 different departments involved. The railway operator was MTR and also was the project manager. Leighton Asia was the main contractor, I think, an arm of the parent Australian company. And the concrete subcontractor became a whistleblower. So 2 years after construction started, when it was nearly complete, it transpired that he was in commercial dispute with Leighton. He said he had photographic evidence of shortcuts and malpractice, which compromised the structural integrity of the works. So he went to the press and the story went viral, and the Hong Kong chief executive set up a high-level commission of inquiry. That's a view, pardon me, of Kowloon from Hong Kong Island from the 8th floor of a solicitor's conference room using just my iPhone. The International Commerce Centre, the high building on the left, is Hong Kong's tallest building at some 108 stories. Hung Hom Station is off the screen over to the right here. So I was appointed to help the Commission of Inquiry to decide if the structures were safe or not. The Commission also had an expert project manager to investigate processes and procedures and what went wrong and why. The hearings were held in the Tsuen Wan Law Courts in Western Kowloon. They had been closed down and mothballed, but brought back into action for this as a one-off. Please keep the image in your mind, particularly those railings in front in the foreground. These ones here, sorry, which are a bit blurred. I have a reason for showing you this and we'll come back to it later. So the east-west line is almost at ground level up here. The north-south line excavation is some 16 meters below ground level, and everything had to be constructed with the station fully live. The roof in that building is a Norman Foster roof. I didn't see any great merit in it, but it's supposed to be a feature. And the length of the underground extension is approximately 400 meters long. That's a very simplistic cross-section with D-wall simply meaning diaphragm wall. I don't know if we use that technique in South Africa or not. That's a more detailed engineering cross-section showing you the main dimensions and slab thicknesses. Groundwater table is very close to the surface and tidal. The close-up on the right shows the junction between the top EWL slab, which is 3 meters deep, and the east diaphragm wall, where embedded mechanical couplers were used to connect the steel reinforcement starter bars of the slab to the D-wall rebar. And I hope this works. This is a quick flick through sequence to illustrate how the extension was constructed. And in the event of the structures needing to be demolished, it's also useful to have this knowledge in one's mind. Okay. So the whistleblower alleged that this photograph, his key evidence, showed threads being typically and deliberately cut off the end of a starter rebar so that less than 10 threads would be screwed into the embedded coupler. In other words, compromising the safety of the works. The allegation related to the bottom of the EWL slab in this little inner circle, where inspection was difficult, whereas the top of slab connection was readily visible to inspectors. And you'll see there the couplers embedded into the D wall during its construction. Those were then exposed during the top-down excavation, and the starter bars shown in blue on the left were screwed into the couplers. However, two types of T40 starter rebar were on site. There was type A with 10 to 11 threads, and that was the bar commonly used for the coupler connection. There was also a type B bar with twice the number of threads, which had been used in the D-wall construction. And that's because a different type of mechanical coupler was used for the D-walls. And so it appears that there were some leftover type B bars on site following completion of the D-walls. I analysed the photograph one night in my hotel room as best I could as I was preparing for the next day's hearing, and concluded that the bar had already been cut in that photograph. It had been cut through and 13 threads were left. So it therefore transpired that there were occasions when the contractor ran out of type A rebar and cut down type B bars to avoid any delay. And the occasional use of those cut type B bars was later proved and confirmed during opening up investigation. The key to demonstrating the criticality or otherwise of this connection is shown on the following bending moment diagram. And I devised this as a means of trying to explain engineering theory to people, to non-lay, to lay people who were non-engineers, such as the barristers and the solicitors and all in the court, and even the judge. This shows that at the D-wall connections, the top of the 3 meter deep slab is always in tension. In other words, the joint is trying to open up, whereas at the bottom of the connection, the slab is always in compression. The joint is always trying to close. So theoretically, no rebar is needed at the bottom of the EWL slab. And this bending moment diagram was very often shown on the big screen during the hearings in court. In fact, at one point when I was explaining the bottom NSL slab, the one at 16 meters below ground level, with its huge hydrostatic pressure uplift, I asked the court recorder, could she turn it through 180 degrees? And she did that, and it was very useful exercise. And then at one of the interim hearings, I was last to give evidence and be cross-examined. It was a Friday afternoon, and I was leaving immediately afterwards to go back to the hotel and then to be taken to the airport for my flight home to Dublin. Counsel for the whistleblower was the last to interrogate me, and I was warned to expect an ambush, some sort of a question for the benefit of the press who were in the public gallery, because the case attracted huge daily headlines in Hong Kong. So counsel for the whistleblower put a question to me, and I quote, "Are you saying that no steel rebar is required at the lower connection? If bamboo was used, it would have the same effect as steel, question mark." So I recognized that as the ambush question, and I thought very carefully, and as previously advised, I kept my reply brief. I simply said, "You have understood correctly." So before I made it back to Dublin, my legal team sent me a photograph of the banners that were put on the railings outside the court the next morning, those railings that I showed you previously. An amazing and fairly sizable work of art. And there I was doing my bit to promote sustainable design by advocating the use of bamboo as a substitute for steel rebar. The other chap on my left was the senior counsel for the main contractor, and the press were having a pop at him too, because they didn't like what was coming out of the inquiry. So the Hong Kong Law Society took a fairly dim view of it all and closed ranks in their colleague and threatened the press with injunctions. Now moving on to talk about cost, and I'm just keeping an eye on the clock. I'm talking about cost generally. All the cases I've referred to, and not just the Hong Kong one, the cost is huge in all of these. A life wasted or a life-changing injury should never happen. And remember that manslaughter in the event of fatality could be corporate, but it can also be individual. And that's when it becomes scary. In other words, you are not protected by your employer's umbrella of insurance. You could be criminally prosecuted as an individual and serve a prison sentence if you are proved culpably negligent. At least that's how it is in the UK. Your Southern Africa countries may be different. Any profit margin built into the project simply evaporates. Thompson Dock and Hung Hom Station are examples of what can go badly wrong. So the bottom line is we all need to get it right. Apologies if any lawyers happen to be listening, because the only winners are the lawyers. And in that last slide, you not only pay consequences in the event of a claim in terms of your insurance PI, there's reputational damage done. You probably will never work for that loyal client ever again. And as I say, you lose money hand over fist. So I've plagiarized a quotation in the next slide by a rather famous person, although I'm not sure he'll really mind. And it simply says, if there were no bad projects, there would be no good construction lawyers. Plagiarized from Charles Dickens. I'm now moving briefly to my final topic, you'll be pleased to note, and that is competence generally and how it should be assessed and tested. The Grenfell Tower tragedy was a game changer, just like Roland Point in the early 1960s. And irrespective of national boundaries, we have a shared responsibility for change, and we are very much in this together. So let me put on record two short key messages from the I-Struct-E that I often gave when I was president and giving talks like these. Firstly, we have a shared obligation to improve our professionalism. This means better sharing of information and learning from beyond national boundaries so that we can gain insight from both poor and best practice, and even learn from terrible accidents irrespective of geography. The Lacrosse fire in Melbourne in 2014, the Grenfell Tower in London 2017, the Torch Tower fires in Dubai in 2018, the APCO Tower in Sharjah in 21 have all been high impact events which could have been prevented. That's the sad thing. In this regard, we cannot afford to become nation-centric. We need to pool our expertise and experience. We need to learn from past failures. And this is where we encourage you, if you have not already done so, to engage with CROSS. CROSS means collaborative reporting for safer structures. And one of I-Struct-E's major ambitions is to continue developing its unique international perspective for professionalism for structural engineers, wherever in the world they live or work. We have also, on the back of the original CROSS, set up subsidiary CROSSes. So there's CROSS Australia and there's CROSS United States. And here's a challenge I'm throwing out to you guys. What about setting up CROSS Southern Africa? You can think about that one. Secondly, the demonstration of competence will be a career-long undertaking in future. And with the Building Safety Act now statute in the UK, I think we all recognise that greater oversight of construction workers and engineers is rapidly coming. And while this concerns both process and competence, we'd like to focus on competence, and our observations from being very closely involved with the UK government in the development of the Building Safety Act as it was when the bill was going through its draft stages. Irrespective of where the initial bar for competency sits in different jurisdictions, and for I-Struct-E, this means examined competency tests, in addition to the academic base and experiential learning, we see a future where there is going to be increased demand for demonstrating specialist skills and experience to work on specific types of structure. So what we see today as chartered or professional grade will be only the starting point, providing entitlement to work only on generalist structures. The higher the risk, then the greater the barriers to practice will become. And we would strongly argue that professional bodies should examine and set those barriers themselves before government and regulators do it for us. So we envisage a future where, and it's already panning out, where there is more extensive use of specialist registers. And certainly in the United Kingdom, the new building safety regulator is already introducing much more rigorous compliance criteria, and iStructE are working with them on this for those designing and constructing high-risk buildings called HRBs. It's only a short matter of time before other types of structures we think will be brought into scope as well. All of this will require new tests of competence, specialist examinations and interview protocols. And this changes as well the whole thinking behind international reciprocity of qualifications. In addition to requirements to join specialist registers, we believe there will also be far more rigor applied to incremental CPD. It won't just be good enough to put down that you're on your child's school board of governors, which counts at the moment as CPD. It will include much more specific and targeted content. Some of it will be mandatory, some of it will be tested. Maintaining chartered or professional status will be dependent on having complied with the CPD regime. And perhaps finally, I'm not sure about South Africa and the other Southern African countries, but in the UK, we believe there will be a need to revalidate professional status, perhaps as often as every 5 years. As I say, this already happens in some countries. The reality of all of this is the profound impact and responsibility structural engineers have for public safety. And as an analogy, after all, we expect nothing less, for example, from our medical professionals. So listen, I've rushed through that at a great pace. It's taken 50 minutes or so fast talking, and I've left out a heap of stuff that I could have added. But in conclusion, our profession is full of risk. Hopefully, we will all become more aware of the pitfalls and work positively to mitigate that risk and raise our game in terms of our competence. That, by the way, is a picture from the Kowloon side of Hong Kong, looking across to the island with its fairly spectacular buildings. So thank you all very much for attending, and apologies if I have slightly overindulged myself.